Hello everyone. In this video, we are going to see another problem in power electronics. The question is, consider the boost converter circuit shown. Assume that the semiconductor devices are ideal. In steady state, the inductor current rises linearly from 0 ampere to 6 ampere in the first 10 microsecond and then falls linearly from 6 ampere to 0 ampere in the next 10 microsecond of every switching cycle as shown. The load resistance R is 10 ohms and the capacitance C is 500 microfarad. Neglect the ripple in the output voltage. What is the input voltage VDC? The circuit given is boost converter and it is given that the current, the semiconductors, it is given that semiconductor switches are ideal. And it is also given that the inductor current waveform it is given. In the inductor current rises linearly from 0 to 6 ampere and then falls linearly from 6 ampere to 0 ampere. And we are given the values of R and also we are given the value of C. And we need to find out the input DC voltage. It is given that the ripple in the output voltage can be neglected. Now, the solution of the given problem is given here. We are given the load that is inductor current waveform, which rises from 0 to 6 ampere in first 10 microsecond and falls from 6 to 0 ampere in next 10 microsecond. So we can see that this is one full cycle. So we can tell that the duty ratio is 50%. So we can take D as 0.5. And we know that for boost converter, the output voltage is V in by 1 minus T. So we can write V naught, that is V out, in terms of V in as V in by 0.5, which can be written as 2 into V in. And now we can find out from this waveform the average inductor current, which can be found by taking the area of the waveform divided by the time period. So this is a triangular waveform. So we can find the area as half into base is 20 and height is 6. So 20 microseconds divided by 20 microseconds. So we can write half 20 into 6 divided by 20. So which will give the value of the average inductor current as 6 by 2, which is 3 ampere. This inductor current is nothing but the inductor current and the source current both are same. So we can write the average inductor current is equal to average input current, that is source current. Now we can write again the output current in terms of output voltages. Output voltage divided by the resistance, load resistance. Load resistance is given as 10 ohms. So we can write output current as V out divided by 10. Now, in order to find out V in, we need to go for the power balance equation, which is nothing but input power. Since the devices are given as ideal, we can write the input power equal to output power. Input power is nothing but V in into input average current, average input current. That is equal to output power is V out square by 10. Now we can substitute V out as 2 times V in as given here, as we found here. And average input current we found it as 3 ampere. So we can write this power balance equation as 3 V in equal to 4 V in square divided by 10. So solving this, we can obtain V in as 7.5 volts. So the correct answer is 7.5 volts. So this is a numerical answer type question. We need to find out the answer and fill the answer. So we found the value of the input DC voltage as that is VDC. Input DC voltage, which is denoted here as VDC, which is equal to 7.5 volts. Thank you.